China built a super tire, breaking the West's grip on high-end tire materials. I saw some news these past few days. A Chinese company just bit into a really hard bone and actually knocked it down. How hard was this bone? Hard enough that the global petrochemical leader, ExxonMobil, chewed on it for nearly 20 years and finally broke its teeth and gave up. What technology are we talking about? It's right under every car we drive, the tire. Don't be fooled by how fast cars are evolving. Flying cars, autonomous driving, smart cockpits, all that high-tech still ultimately transmits force to the road through 4 narrow tires. A tire looks simple and black on the outside, but it's actually complex inside. Roughly 3 layers: the tread for grip and wear resistance on the outside, the carcass that carries the load in the middle, and then a critical inner layer most people never see: the airtight layer, or innerliner. The innerliner has one job: hold the air in. Over the last 80 years, materials for tread and carcass have changed a lot, but the innerliner stayed almost identical across global tire makers: butyl rubber. It was invented in 1,943 inches, the US. It works, but it has a big flaw: it's heavy. One car tire's innerliner can weigh nearly 3 pounds. With EVs racing to reduce weight to gain range, those 3 pounds must go. Back in 2008, ExxonMobil developed a revolutionary new material, DVA. It was amazing, 10 times better at blocking gas than the old material, and could shave about 1 kilogram off a tire. In tire terms, that's a bombshell innovation. So why, nearly 20 years later, don't you see DVA tires on your car? ExxonMobil quietly shelved the project. I dug into the records and found the problem wasn't the material itself, it was landing it in real factories. ExxonMobil is a chemical giant and approached this like a chem company: make the perfect material in the lab, then sell it to tire makers. But tire makers were stuck. Old butyl rubber behaves like sticky tape and easily adheres to tire inner walls. DVA, by contrast, was slippery, like plastic film, it wouldn't stick. ExxonMobil shrugged. My material is perfect. If it won't stick, your process is the problem. Change your lines, buy new equipment, that's arrogant. Asking tire companies to tear down and rebuild billion-dollar production lines for an unproven material was asking too much. So even ExxonMobil died on the last mile of commercialization. So how did a Chinese company succeed where ExxonMobil failed? It's a movie-worthy story. The protagonist is a Shandong materials firm called Dawn. At first, they were clueless, no formula, no equipment, so they reverse engineered it, spending 12 years in the lab to match ExxonMobil's material performance. But that was only the first mile. When Dawn brought their perfect lab sample to a tire plant, the same problem showed up. The new material lacked adhesion and couldn't run on existing lines. Here, China's industrial chain advantage kicked in. In many countries, this would have died. But in China, suppliers and manufacturers cluster tightly and collaborate intensely. Dawn and tire maker Linglong sat down and hashed it out. They decided not to force the production lines to adapt to the new material. Instead, they'd make the material fit the lines. This was a radical idea. Chemical production normally delivers stable, finished products. But the Chinese team decided, we won't give you a fully finished material, we'll give you a half-cooked material that's still reacting. It's like sending a live volcano onto your production line. Why? Because this half-cooked material only has a short window of tackiness, just a few dozen seconds during which it will adhere to existing tire processes. To catch that window, they even redesigned reactors. Traditional batch reactors were too slow, so they invented a pipe-reactor system where the material flows like a high-speed train and reaches the exact reaction point at the exact time required. 1 second too many or too few and it fails. After countless explosions and clogged pipes, the Chinese team turned the impossible into possible. Now they can stabilize that adhesion window to over 15 days, long enough to produce and ship globally. Think about why ExxonMobil failed. They had a supplier mindset. I give you my material, you adapt. Why China succeeded? An industrial chain mindset. China has the world's largest NEV market, and new car makers constantly push upstream suppliers with almost obsessive demands. More range, lower noise, higher safety. That pressure cascades upstream and forces tire makers and material suppliers to innovate. Under that pressure, relationships stop being simple buyer-seller transactions and become trenchmate partnerships. Materials firms that can't solve a problem get hands-on cooperation from tire makers. Tire makers pull in universities for help. That's the strength of China's ecosystem, not just factories, but a living, self-evolving industrial cluster. Before, we talked about overtaking on a curve because we were behind. Now, in the brand new space of EVs and related tech, there's no established road ahead, and China's massive clustered supply chain is jointly forging a new path into unknown innovation territory. This time, it was the innerliner. Next time, it could be some other field we never imagined another act of Chinese-style comeback. That's the hardcore confidence of Made in China. If you want to learn more about China's latest tech news and see China's unique perspective on its technology, please like and subscribe.